Suppose a population increases from 2.5 million at a continuous growth rate of 1.3% each year. I'd like to do several things. First of all, I'd like to write the equation modeling the situation. Notice we are told the growth rate or the growth is continuous. Since we were told it's continuous, we will use our formula that would say f at t is a e to the kt. Again, we use this formula because of the word continuous in the problem. Notice our initial value, which is our a, will be 2.5, and I chose to use 2.5 and not 2.5 million, not do 2,500,000. The numbers will just stay smaller that way. The population increases, so our k is positive as I use my formula. And so k as a decimal would be 0.013 because it was 1.3%. And now if I write the formula and put it all together, I get f at t is 2.5 e to the 0.013 t. Very simple, very easy, much easier than what we were doing in the earlier part of the chapter. Part B. When will the population reach 7 million? So now what I want to know is when will the function that I just worked with equal 7? And again, since I use 2.5 and not 2,500,000, I will use just 7 instead of the full 7 million. So I have 2.5 is e to the 0.013t equals 7. And again, because we technically haven't learned to use logs yet, we're going to use our graphical approach and our intersect feature on our calculator. And if we do that, we get t equals 79.2. And so what we learn is in approximately 79.2 years, the population will reach 7 million. Again, once we know the logs, or if you feel comfortable using logs, you could probably solve the equation right out. I actually prefer to do that, but the textbook hasn't yet taught us about solving with logs.